So in this section, there isn't really any writing that you're going to have to do, it's just more so paying attention. These are some properties of the sine and cosine functions, and they're actually extremely important characteristics of the graph. So I'll focus on the sine first. And for a sine graph, my domain is negative infinity to positive infinity, because basically, even though we will only be sketching one portion of the graph is continuous. It doesn't end, and there are no breaks in the sine graph. My range is from -1 to 1, meaning how high and how low the graph goes, for the parent function, meaning nothing is happening to it, just like the parent function of x squared has a vertex at 0, 0, and so on. Okay, the more important pieces here would be something like the symmetry. So in this case, we have symmetry with respect to the origin, which is an odd function, so that means we have the opposite. So what that means is, if I take a look here at my graph, I have this point up here, this is pi over 2, 1, meaning if I take the sine of pi over 2, I get 1. So then this is symmetric with respect to the origin, so that means I have the exact opposite point down here, which is negative pi over 2, negative 1. So if you recall from an odd function, you have the opposite of f of x is equal to f of negative x. Okay? Okay, let's focus on the cosine function here. So in the example of the cosine function, again, the domain still goes from negative infinity to positive infinity, and I have a range of -1 to 1, and if you look at this cosine graph, it looks exactly the same as the sine graph. The only difference here is that when you take the cosine of 0, I'm up here at 1. So the graph starts at 1 here, whereas the sine graph starts at 0. Okay, so they are embedded in each other. The problem, or the difference, is that the sine and the cosine start in different spots. So the cosine has symmetry with respect to the y-axis. It's an even function, which means f of x is equal to f of negative x. And this is very similar to a parabola, meaning if I were to take this paper and fold it on the y-axis, I have an exact carbon copy on the other side. Okay, so one thing I want to point out is when we start graphing, we will be using terms like min, max, intercept, and in this case, this value and this value will be my minimum, so I'm using a lowercase m, and this value right here is my uppercase, which is a capital M. It's my highest value, meaning lowest value on the graph, highest value on the graph. So what I'm going to cover right now are some key characteristics of the graph, and these are on the next few pages in your notes. So what I did was I highlighted a standard function here. So this is on page 3. And what we're looking at is just a standard. It could either be sine or cosine, it doesn't matter. But when you write the function in standard form with all the pieces, this is exactly how it will look. And each letter, A, B, C, and D, represents something that happens to our function. So if I take a look here, A, which is going to be the coefficient of either sine or cosine, represents the amplitude. And basically, it is the height of the graph, how high or how low the graph goes above or below the baseline, or in this case, the x-axis. Okay, so that's a key piece. Then if you notice, there's a negative in front. This negative affects the reflection across the x-axis, meaning if this is my original parent function like this, if my function then became negative sine, see right here, that means this whole graph just flips over, or as we say it mathematically, reflects over the x-axis. Okay, so we have to look for these key pieces. The next piece that would be here is a b value that is factored out of this quantity, and the b value relates to the period, and it is how wide or how far out the graph goes. So a standard period of our function, a parent function, is 2 pi. And really what this means is if we have the sine of x, my coefficient here is 1. And what that means is we have one cycle in 2 pi. If I have the sine of 2x, This right here means I have 2 cycles in 2 pi, meaning here, 1, it would be more like 1, 2, and it would come all the way up here. If I had something like the sine of 1/2 x, this would mean I have half of a cycle in 2 pi. Okay, so this means 2 cycles in 2 pi, half of a cycle in 2 pi. And this is important, okay, because it's going to affect what our graph looks like. Okay, so still keeping this standard form in mind, we need to consider, what about C? So C is what's called our phase shift, okay, and it is a horizontal shift, which means the graph is going to move either left or right. Okay, either left or right. And then the last piece is this D, and you notice it's on the outside. Okay, this is a vertical translation. Okay, meaning your graph will move either up or down, and it's going to change our baseline. Okay, so for example, I could have something like this. This is my parent function. This means the graph of sine moves up 1. Okay, so before I had stated that we were going to be using min and max terminology. So just so you know, something like this, if I have the sine of x, I'll just use the sine. It doesn't matter if it's the sine or the cosine. So I'll do the sine of x first. Okay, and the sine of x starts here. So I'm going to call this the intercept, and I'll use an I. Then the next key point is going to be up here at a max with a capital M, then back at the intercept, then down at my min, and then back at my intercept. So the key thing here is I'm moving around the unit circle, and I'm using the quadrantals for the parent function. Look at this. This is 0, pi over 2. This would be pi, 3 pi over 2, 2 pi. Okay? The pattern will be the same. So if I use the cosine, which is here, okay, the pattern is not going to start with the intercept. It's actually going to start at the max. See, it's the highest point here. Then it goes to the intercept. Then we go down to our min. Then we go to the intercept. And then we're back up at the max. Now, something I want you to think about is what happens with the reflection over the x-axis.